So welcome to this discussion as we try to give you some quick revision concept under magnetism. So what is important is of course for you to understand or to remember what we call as being properties. So you need to remember properties of magnets. Yeah, so you need to remember properties of a magnet, and one of the properties that I can give you that all magnets, so we can simply say that all magnets are characterized. So all magnets are simply characterized by pole. That's what you need to remember. Now a pole is simply a charged region around a magnet, and that pole can either be positive, in this case that's considered to be north, or it could actually be negative, and that is simply considered to be a south seeking pole. So all magnets are characterized by poles. Then the other thing that we can talk about, another property that we can talk about is that magnetic all magnets attract magnetic materials. So we can simply say all magnets attract magnetic what we call as being magnetic materials. Now what exactly magnetic materials? Sometimes they are called ferromagnetic materials. These are materials that can be attracted to a magnet, so we call them as being magnetic materials. And in the exam they are going to ask you to give examples of magnetic materials. So very important that you know some examples. People confuse them, but I want you to remember this. I need complete silence. So this is going to help you with your memory aid, where I simply stands for iron, then N simply stands for nickel, and the C stands for cobalt, and the S there stands for steel. These are what we simply call as being magnetic materials. In simple terms, they can simply be attracted, or they can get attracted to a magnet. So iron, nickel, cobalt, and iron are the only good magnetic materials that you need to remember. The third property that we can talk about of a magnet is that poles repel. So like poles repel, then unlike poles attract. So now this we have stated here is what we call as being the law of electromagnetism. So they are going to ask you, state the first law of electromagnetism. Like poles repel and like poles attract. That's what you need to remember. Then the last but not the least property that I can talk about is that when freely suspended, so when a magnet is freely suspended, it comes to rest in the north-south direction. So that's the way it is. When a magnet is freely suspended in air, what I mean is that you get a magnet freely suspended in air using a string, it will always come to rest in the north, pointing in the north-south direction. That is what you need to remember. These are important properties of all magnets that you need to remember. Now when you talk about a magnet is capable of producing what we call magnetic field. So when we talk about magnetic field, a magnetic field is a region or an area, around a magnet. So a region around a magnet where it exerts its greatest force of influence. So a region around a magnet where it exerts its greatest force of influence is what we simply call as being a magnetic field. And usually the magnetic field is actually concentrated around, in this case, the poles. So for example, you have got a north and you also have a south pole. So you are going to find that the magnetic fields are going to be concentrated around the field. So that is what you need to remember. So now, when I look at, if this is a magnet, how do you draw? The magnetic fields are simply represented, these magnetic fields are simply represented by what we call as being magnetic field lines. So they are represented by magnetic field lines. So they can tell you to draw the magnetic field lines around what we are calling as being a magnet. So how do you draw them? Well, magnetic field in the north pole, they are moving out, but in the south pole they are entering. So they should move always from north and they go to south. So from north they go to south. So that's the way the magnetic fields are going to be moving. So again, as you are drawing them, the magnetic fields do not cross each other. So as you draw them, they shouldn't be crossing each other. Then when you are drawing them, the number of fields that you have up there should be equal to the number of magnetic fields that you have down there. So that is basically the basic idea that you need to remember when it comes to magnetic field around a magnet. So you can actually get to do that. But suppose you have what we are calling as being, you have actually unlike poles. Remember what we said, unlike poles do what? They attract. So there's going to be attraction that is going to be there. So for example, if I've got two unlike poles, they are actually brought together, maybe a north and a south, then it simply means that the magnetic fields will run from the north to the south. They'll run from the north to the south. And that's what you need to remember. Why? Because there's going to be attraction that is going to exist. So the direction of the arrows will always tell you the direction in which the magnetic fields are moving. Now at some point, you can also have what we are calling as being unlike poles. So you can also have what we call, you can have like poles. Let's use in this case, like poles. So when we are using like poles, when they are like poles, you are going to see that there's going to be repulsion. That's the idea that you need to have. So for example, you can have north and north, or maybe you can have south and south. Maybe let me say you have got north and north, and there you have south and south. It simply means that when you look at the magnetic fields, the way they are going to appear, mind you, they never cross each other. So when you draw them and they are crossing each other, it simply means that what you are going to be doing in the exam is going to be wrong. So because north and north, they are moving out. So your arrows are going to be going out because that's the north pole. So they'll both be moving out. Then if it is a south pole, you expect the arrows to be pointing inward because they are coming in or entering. That's the way it is. And just by looking at the arrows, you can tell whether this is south and this is north pole. So you should be able to tell. Now, there's a certain region right in the middle of two like poles that we simply call as being a neutral. We call it as being a neutral point. So the point between two like poles where the magnetic field cancel themselves out, that is called as being a neutral point. Why? Because the magnetic fields are going to cancel themselves out. So that region is simply called a neutral point. So because it's between a magnet, there's nothing wrong with you calling it as being a magnetic neutral point. Why? Because it's existing between two magnets, but the region is simply called a neutral point. Let me just show you a question paper, and how you could have gone about it using that idea that you have. By the way, before we look at such a question, remember that the only surest way to tell that this is a magnet, the only surest way to test or to tell that this is a magnet is actually repulsion. One of the sides should be able to repel. So if you have a magnet you know, there are two properties that are there. They could either be attraction or they could actually repel. So repulsion is the only surest way to tell that this is actually a magnet. Now notice what the question there was saying. The figure below shows a bar magnets with different poles. So there are 1, 2, 3, 4 bar magnets, and they have been given letters that are there. So they want you to identify. They want you to identify the poles. The following. Identify the following poles. What is, you know, what is P, what is R, what is T, and what is Y. Now if you notice here, the arrows are going in that direction, meaning that this should be a north and that should be a south. And if this is a north, you can see the arrows are entering. That automatically tells you that is a south. And you can see again where V is, the arrows are entering, meaning that that is a south. You can see where T is, the arrows are moving out, that tells you that is a north. And these are moving out where Y is, that tells you that is a north. It means automatically that that one is going to be a south pole. I hope you are clear from where we started from. So if you look at P, you know, P is simply a south pole. What about R? Again, R is simply a south pole. What about T? If you notice from what we did, T is actually a north pole. And what is Y? Y again is a north pole. So you can see it's very simple in this exam, so you are able to tell. If I told you to label from this diagram which one is a neutral, which one is a neutral point in this case, yes, here and somewhere here, it simply means that these regions here are representing what we are calling as being the neutral point. So a neutral point is a point between two like poles where the magnetic fields cancel out, and that's what we call as being a neutral point. So you can look at other things, how to magnetize and demagnetize, you know, a magnet in my other videos. But you also need to know what we call as being magnetic induction. So magnetic induction. Watch out in my other videos and you'll be able to learn something from there. Thank you so much for watching.